Here's another question, guys. The electrochemical cell, which is it's the galvanic. Now let's cut the chase. Consider the cell below, which operates under the standard condition. That's important. Now it says, if you look here, guys, we have an iron and we have the manganese. And which ions? There are a lot of ions in the table, and there are three types of iron. We have this iron, and where's another one? We have that one. So it's this and that. But which one are we using here? The one that we are focusing on, guys, the electrolyte here that we're given, we have an iron chloride, which is the iron trichloride there. That means the iron is the 3 plus. We see by that 3 there. So we're going to choose with the 3, the one with the 3. So which is going to be this one, which is going to be this one. We're going to use this one, right? And then the magnesium, it's going to be that one, right? So the other electrode, it has the magnesium, and this one, it has the iron. So the magnesium, since it's at the top, so that means this electrode is an anode, and this one is the cathode, right? So the anode is negative and the cathode is positive, right? So guys, now we know the oxidation occurs here and the reduction occurs here, right? Now let's answer the questions, guys. And we're given the soul bridge there, and the soul bridge is X, and they have the voltmeter reading there. Now it says, at which half cell, Fe or Mg, are the electrons released from the external circuit? The electrons are released from an anode, so the electrons, they move from there to there, from an anode to cathode, which is an Mg. So the answer there is what? Is Mg from the magnesium. The table state that the magnesium, it's at the top there, right? Now let's answer 3.2. Write down the energy conversion that takes place in the cell. The energy conversion that takes place in the cell, guys, it's chemical to electrical all the time. Chemical to electrical. You need to write that in full, guys. Now, one standard condition required for this cell to operate. So one standard condition there is the concentration. The concentration here is 1 mole per dm3, right? The concentration of this electrolyte, it needs to be 1 mole per dm3. One function of the label part X. Label part X is the soul bridge. It completes the circuit. It completes the circuit, and there are more. The net cell there, guys, let me write 3.4. Okay, the net cell, guys, here I'm gonna write it. The net cell, guys, let me write it here, 3.2.4. I need to write the half cells. I'm gonna write the oxidation here, which is the magnesium. It's oxidized to Mg2 plus the 2 electrons. And then the reduction. Reduction, guys, make use of the table. Do you see? I started the magnesium that way and I wrote it that way. So I'm here now. So guys, remember, we've used the one with the 3 electrons and the 3 charges and the 3 electrons, not this one, and not, where's the other? And not, I've shown you guys, we did not use this, and the other one. Okay, so the reduction here, guys, is going to be Fe 3 plus 3 electrons, and it's going to be what? Fe. Right, so this is not balanced, guys. In order to write the net, these must be balanced. Do you see here there are 2 electrons and there are 3 electrons there? So we need to balance this, guys. Now balancing this, I need to multiply. So we have 3 and 2. So what are we making 3 and 2? And 3 and 2, it's easy to make them 6. That means here we are going to times by what? 3 to make it 6. And then the 2, we times it by the 3, we times it by 2 to make it 6. So the new now oxidation half reaction, it's going to be 2 magnesium. We times everything by this 3. We times this, we times this, we times that. So it's 2 magnesium arrow, not 2, it's 3. It's 3. It's going to be 3 magnesium arrow and 3 Mg2 plus, and 2 times 3 is going to be what? 6 electrons. And then the reduction, we times everything by 2, this by 2, it's going to be 2Fe3 plus, and then this by 2 is going to be what? 6 electrons arrow, and then 2 times this is going to be 2Fe, right? So the net cell reaction now, the net cell, which is the balancing of that, this and this cancel, so we're going to write the reactants. So it's going to be 3 Mg plus 2 iron plus, and then our the product, it's going to be 3 Mg2 plus, and then that is going to be 2 iron there, right? So that's what we have, the net cell there. Okay, now going to the 3.3 question, it says after the cell has been operating for a while, it is determined that the mass of the magnesium electrolyte changes by 0.96. What does it mean? Since this is an anode, we know in an anode, the electrode that is undergoing oxidation, there's a decrease of mass. So the decrease of mass, it decreases by 0.96. Now it says calculated the change in mass in an ion electrode over a period of time. So if this one, it decreases by 0.96, and this one will also increase, but we want to know the increase. What will be the increase? Remember, in the cathode there's an increase in mass, so we wanted the increase of that. So if you check one of my previous video, the introduction to electrochemistry, I explained that 3.3, guys, we're going to need the net cell here. That's why they asked you before, the net cell is important in this question. Right, here's our net cell here. So what do we have? We have the magnesium changes by 0.96 gram. So we want to know the iron, it changes by what? So the first thing that we're going to do, step number 1, we're going to change the mass of magnesium, the mass change of the magnesium to number of moles of magnesium, right? So let's do that. So doing that, so I'm going to say number of moles of magnesium is equal to mass over molar mass. So which is the mass, it's 0.96, we divide by the magnesium is 24. The answer, when you punch that in the calculator, it says 0.96 divided by 24, it's going to be 0.04 mole. Right, going step number 2, now that I have the number of moles, I'm going to use the mole ratio for what? The mole ratio to determine the number of moles of what? Of iron using the number of moles of magnesium, right? So here's the mole ratio, iron is to magnesium. And the ratio between, what do you get the ratio? Is 3 is to 2. 3 is to 2. So magnesium is 3 and iron is 2. Right? Yes. Then we are looking for iron, we put X there, and the magnesium is 0.04. So if you cross multiply there, so your X is going to be 0.0. You're going to have 0.08, you times by 2, and then you divide by 3. Your answer here, it's going to be 0.026 66. Remember, we can round off before we get to the final answer. And then step number 3. This is the number of moles of what? Of iron, right? So I'm going to change the number of moles of iron to the mass of what? Of iron. That's the mass change of iron. So I'm going to say number of moles is equal to mass over molar mass, and then I take the number of moles, which is I still have in my calculator, 0.02666, and then I want the mass and the molar mass of iron. The molar mass of iron is 56. Is 56? No, not correct. Let me double check. The molar mass of that, I am not sure. The mass of iron, yeah, it's 56. So if it's 56 and I times by 56 there, so when I cross multiply, I use the answer on my calculator. So the mass of iron, which is the mass change, it has increased the mass by 1.49 grams, right? This is the mass change, or the mass increase of iron. Okay, now let's go to the last question. 3.4, it says the solution of magnesium ion is added to the magnesium chloride half cell. What does it mean? That means the ions, they added a solution there, which means, in other words, they increase the concentration of magnesium, the magnesium ions that are in the solution of magnesium chloride. So the question obviously is going to ask the EMF. It says what effect, if any, will this change on the voltmeter reading? Write down increase or decrease or remain the same. Use Le Chatelier's principle to explain. Okay? Using this question, guys, we'll need the net cell all the time. It needs the net cell, this type of question. Okay, let's write it there. This is a 3.4. Guys, the net cell doesn't have an answer. It doesn't have marks for this, but it helps you. So the magnesium ions are increased there in the solution. The system responding by decreasing them, right? Decreasing them. That means the magnesium ion is the product. That means the products are decreased. The reactants are going to be what? Increased. That means the reverse is favored and the product is not favored. So how do you answer this? So the reverse is favored here. When the reverse is favored, the EMF will decrease. So the answer here is what? Is decrease. Decrease. And why? You will say the reaction, the system favors the reaction that decreases the concentration of magnesium ions, right? So what are we saying? What are we saying here? We say the system, it opposes what has been done. The concentration has been increased, it decreases. And then which one is going to be favored? What is going to be favored? Reverse reaction is favored, right? And guys, and that's it. That's how you explain according to Le Chatelier's principle. Thank you guys so much. Cheers. Bye.